Okay, welcome to Calculus Homework. Today we have our special guests for page 289 and page 290. We have Holly. Say hey, Holly.
Hey.
And Erica.
Hello.
And Nick.
What's up?
Aaron.
Hey.
And Will.
Howdy.
All right. And we are going to start by working this problem. And we first of all have a rectangle, so we'll draw that rectangle. And this time we're talking about the area, so we need our area formula, which is area is equal to what? Length times width. Okay, now what we need to do is to take their words and write them in calculus. So what about that first part, Will? What is that saying?
That's saying it's going to be a negative 2 centimeters per second.
Okay, and that's the what? What's changing?
The length of the dy over dt.
The C, R over over dt. And what kind of 2 will that be then?
Negative, because it's decreasing.
You got it, okay? All right. And then what is this telling us, Aaron?
That the width is increasing.
And how do you say that in calculus?
dw over dt.
Okay. Positive or negative?
Oh.
Okay. All right. And so when we're given this information, we want to find the rate of change of the area in this one. Both length and width are changing, so we're going to have to do implicit for both variables.
Yeah.
Okay, and that means we'll have to use what rule? Okay, so get us started. Erica, the d8 over dt, and how do you do product rule? It's going to be what? First
times derivative of the second plus second times derivative of the first.
All right. Okay, and then once we've done our derivatives, this is what we are looking for. So what do we plug in here for L?
12.
Okay. And then dWdt is going to be what, Aaron?
2.
Right. What about dLdt, Holly? And then W is what, Erica?
Oh,
Okay. All right, and bring it on home for us, Aaron. That's going to be what? Which is 14, and remember that was dA over dt. So, Nick, what's our units for area in this problem?
Centimeters.
Centimeters.
Wait, just a second.
Right, because it's area, right? And what about our time unit?
Centimeters per second.
Let's see, time unit. You see, centimeter squared is area. Time is in what in this problem?
Second.
Right. So at that time, is the area of that rectangle increasing or decreasing?
Increasing.
Okay, we got it. All right. Let's look at the next one. Same rectangle, but now they want to know about the perimeter. And what's that formula again? Perimeter is equal to what? We got it. Okay. So we're going to need to do the derivative. All right. Talk me through the derivative, Holly.
okay. You take the perimeter and make it d over dt, and then 2 dl over dt plus 2 dw over dt.
Okay.
And then you plug it in.
And then plug in. All right. And we have those same units. dl dt is what again?
-2.
And then dWd2 is so what about the perimeter then?
0.
Okay.
So the perimeter is a change.
Okay, so, yeah, so that's that, so the perimeter, okay, it, can't change. And let's see, the perimeter wouldn't change, because I guess L and W, they're stuck with those numbers, right? Yeah, so your perimeter's gotta stay there. Okay, last one, length of a diagonal. Width, length, and we are looking for diagonal. And what was that formula again for the length of that? It'd be what?
D squared equals W squared plus L squared.
Right. All right. And Will, what about our derivatives? Yeah, for this one.
Would be dd over dt.
Hang on just a second. Okay, first of all, we gotta do that two.
So this was 2.
Two. Bring that down to the front.
Do 2d over dt.
D. Well, so you need 2D, and then the implicit would be what?
D
Okay. All right.
dd
Over dt. Yeah. All right, like these. All right, Aaron, what about W?
It would be 2w dw over dt.
All right, because it's all changing. And then Erica, what about the length?
It would be 2L dl over dt.
Okay. So now we can fill in stuff. Okay, and we want the rate of change for that diagonal. So that is what we are looking for right there. The change in D over time. And we know this is 512. Do we know what D is equal to in this at this moment? Because why? That's a 512.
So 13
Okay.
Pythagorean.
Okay, exactly. So D is 13. We're looking for this. Equal to, and what's W next? It's W is 5. And what about the change in W over time?
That was 2.
Okay. And then Aaron, what's L?
12.
And then Will, what's the L over dt again?
-2.
All right. So keep on going. So 2 times 13 is what?
26.
26. And we're looking for this. All right, bring it on home, Nick, for us. 2 times 5 is, times 2 is 20. 2 times 12 is
24.
times -2 is
-48.
gotcha. All right, and let's see, 20 minus 48 is what? Well,
No. -18.
let's see, 18 or
28.
yeah, -28. Okay. All right, what now, Erica?
26.
So we can just reduce that fraction. That's going to simplify to what?
1
1
and 2,
and
26, which would be 1 and 1,
13.
13. And since that's a diagonal,
2%.
okay, per second. So at this time of the problem, the diagonal would be increasing or decreasing?
decreasing.
Ah, gotcha. Okay, 13, we have got a spherical balloon, okay, with its formula, and that's volumes, so that V equals or it's pi r cubed. We do not need to remember that formula for the AP, although it comes in handy sometimes to know that formula. Tell me what the derivative, Eric.
We do dv over dt.
dt equal to, help me now, Nick, 3 times 4/3 will be just what? Thank you, pi r squared, but then I got to also remember to do what? D,
WDR.
RDT, okay, since, okay, the radius and the volume are both changing, we have to do implicit differentiation for both. Okay, and let's see, we are looking for what in this problem, by the way, dVdt or dRdt? Alright, so we are looking for dRdt. Okay, so what information have you been given?
It's the radius is 5. And
Radius is
You're gonna
5,
do DVT.
and what's the area?
DVT is 105.
Okay. Okay, and so finish solving that. Tell me how to solve that, Holly.
You leave the 100 pi alone, and then you square 5, it's 25.
Times 4 is
100 pi dRdt.
what's our next step after that, Nick? We're looking for dRdt.
Then you would divide 100 by
Uh-huh. All right, and so right, that gives us 1 equal dRdt.
so dRdt would be increasing.
1, what's our units for radius?
Equal.
Okay, and this problem time is 10 minutes. Okay, and that's that one. All right, now for our last problem. Okay, we want the surface area, and that surface area formula is
4 pi r squared.
and so do our okay, so Erica did the derivative for us.
I did ds over dt equals 8 pi, and then
8 pi
dr.
r. So you need
Yeah,
r.
r times dr.
Okay, and so let's go ahead. We're looking for, what are we looking for here? We're looking for,
Surface area.
so we're looking for ds dt. So what do we plug in?
5 for r.
All right, and then the rdt,
Would that be 1 since you already did it?
right, we have that from the previous problem.
So dRdt would just be 12.
So the answer, all right, so ds dt will be equal
45.
to
45.
40 pi. Okay, surface area, area is in what units? Feet squared, and what's the time? All right. So that would be our answer. Okay, and that concludes tonight's homework. Thank you, class, for helping me. Take that, Katy Perry.
That's right.
All right.
Well, that's Katy Perry, actually.
Well, she's jealous. She's envious that she could not be here.
That no, bro.